Today I'm going to be doing 4 problems on least squares, regression lines, least squares, regressions, and residuals. Problem 3 is going to be probability and Venn diagrams. And problem 4 is going to be probability in two-way tables. I'm going to put up problem 1 right now. Okay, so problem 1. The first question is, what does the slope of this line say about the relationship between price and the age of the car? So let's go ahead and write down our equation, and it is price equals 18,500 minus 1,250 times the age. So in this problem, we're wondering, what does the slope of this line say? So first of all, we have to find what the slope is in the problem, and that is negative 1,250. So let's just go ahead and write down that slope equals negative 1,250. So what this means is, for every additional year of age, the car's price decreases by 1,250 on average, because it is a negative. So car price decreases by 1,250 on average. Okay. Then question 2 is, what is the predicted price when the age of the car is 0 years? How would you interpret this value? So what we need to do is plug in 0 for x, which is the age. So we want to do 18,500 minus 1,250 times 0. And that will end up equaling 18,500, which is the predicted price. So the interpretation here is, this represents the estimated price of a brand new car of this model. Okay, then we go to question 3. Predict the price of a car that is 5 years old. So we're basically doing the same equation, but plugging in 5 for the age, which is x. So 18,500 minus 1,250 times x, which in this equation is 5. And that will end up equaling 18,500 minus 6,250 equals 12,250. So what this means is that at 5 years old, the predicted cost is going to be $12,250. Okay, then we go on to question 4. Would it make sense to use the model to predict the price of a car that is 25 years old? Why or why not? So for this question, no, it would not make sense to use the model to predict for a 25-year-old car, because it's outside the realistic range of data. So the answer to this question is no. Okay, then we go on to problem 2. And I will put that up now. Okay, so we have our data, and that is equals 70.243 minus 0.329x. So problem 1. Make a scatter plot of the observation and draw the regression line on your plot. So let's go ahead and draw a scatter plot. So on this side, we are finding the fuel, which is y, and the speed on the x-axis. So fuel will just go by fives from 40, so 40, 45, 50, 55, 60, and 65. Then the speed will count by tens from 20, 10, or 20, 30, 40, 50, 60, 70, until we get to 80. So let's go ahead and look at these plots. So at x, whenever it is 20, the fuel is at 49.0, so close to 50. Then at the point 30, the speed is 30, and the fuel is 67.9. So that is above 65. We'll go ahead and just do 70. Okay. Then at the speed being 40, the fuel is 66.5. Just above 65. The speed 50, the fuel is 59. So just below 60. And then the speed being at 60, the fuel is 50.4. So just a little bit above 50. The speed 70 has a fuel of 44.8, so right below 45. And then we have the speed being 80, which is a 39.1 fuel, so just below 40. And then to draw the regression line, it is this because the negative slope. Okay, then we go on to question 2. Would you use the regression line to predict y from x? Explain your answer. Yes, but cautiously. The model is reasonable for interpolation inside the observed speed range of 20 to 80 miles per hour. So the answer to this question is yes, but cautiously. Then we go on to question 3. Verify the value of the first residual for x equals 20. Verify that the residuals have some zeros up to round off arrow. Okay, so what we want to do here is multiply the slope by 0.329 times 20. So we're multiplying the slope by 20, and that will get 6.58. Okay, then we want to compute the predicted value. So by doing this, we do 70.243 minus that 6.58 that we just got, and that will end up equaling 63.663. Then we want to subtract 49.0 minus 63.663. And we are doing 49 because we're finding the x value of 20, and that on the plot is 49 fuel. So then we will get negative 14.66. And then question 4. Make a plot of the residuals against the values of x. Draw a horizontal line at height 0 on your plot. How does the pattern of the residuals about this line compare with the pattern of the data points about the regression line in your scatter plot from part A? So we're making a scatter plot here, and we're doing the residuals. versus the speed. So residuals is going to be your y-axis, and then your speed is going to be the x. So you can see on the plot on this problem, the residuals are on the far right. So we'll do -15 and count by 5, -10, -5, 0, 5, 10. Okay, then we want to do the speed, 20, 30, 40, 50, 60, 70, and 80. Okay, then we want to connect these on the plot. So whenever the residual, we'll start with the speed. So whenever the speed is 20, the residual is -14.67. So just below 15. Then when the speed's 30, it is at a 7.51. So in between 5 and 10. And then the speed being 40 is at 9.40 residual. So almost 10. Then the speed being 50, it is at 5.19, so just above 5. Speed is 60, the residual is -0.13. So just below 0. And then the speed at 70 is -2.44, below 0. And then the speed at 80 is -4.86, so just above -5. And then we need, it says to draw a horizontal line at a height of 0. So we'll draw a horizontal line at the height being 0. And that is the scatter plot for 4. Then we move on to problem 3. And I will put that up now. Okay. For problem 3, we are going to be drawing a Venn diagram. And it is given the data of people hired in the past 5 years, given these possibilities that are up on this problem. So question 1, sketch a Venn diagram of the events A, B, C, and D, and mark on your diagram the probabilities of the combination of psychological assessment and leaving or not within a year. So we have Venn diagrams A, B, and C, and they are not touching each other. A, B, and C. And then we have the diagram D, which is touching the other diagrams. So we know that possibility of A is 0.4, and the possibility of B is 0.3, and the possibility of C is 0, or probability of C is 0.3. So the problem that I pulled up, we know that this shaded area is 0.1 or 10%. And then this shaded area for B and D is 0.1, so it's also 10%. And the shaded area for C and D is 0.20, 20%. And that is the Venn diagram. Then we go on to problem 2. What is the probability of D, a probability that an employee leaves within a year? So to find the probability of D, we have to add all the probabilities. So probability of D equals probability of A everything plus probability of B. So this is what our equation looks like, and we're just going to plug in from there. So probability of D equals 0.1, this is this equation, plus 0.1 again, which is this, and then plus 0.2, which is this equation, equals 0.4. So probability of D equals 0.4, but this is actually 40%, and this means that 40% of all employees leave within a year. Okay, then we go to problem 4, which I'll pull up right now. Okay, first question asks, if you choose a degree recipient at random, what is the probability that the person you choose is a man? So looking at this diagram, we need to find the possibility of it being a man. So we want to find the total of men divided by the total of people. And those numbers are 1657, 1657, 3990. And we just divide that and get 0.4153, which in percentage is 41.53%. So 41.53% is the probability of you choosing a man. So question 2 asks, what is the conditional probability that you choose a man given that the person chosen received a master's? So we want to find probability of a man that has a master's degree. So we want to find men with masters but divided by the total of master's degree. And these numbers are 340 divided by 813. And that will get you 0.4185, which is equal to 41.85%. So 41.85% is you choosing a man that has received a master's degree. Okay, then we go on to question 3. Are the events choose a man and choose a master's degree recipient independent? How do you know? So to find the probability of a man, we know that that is 41.53%. So we'll go ahead and just write that down. Equals to 41.53%. Now we need to find the probability of one choosing a master's degree recipient. So that is what we did here. And that was 41.81%. 85%, sorry. The answer to this question is no. They are not independent because they are not exactly the same. The events are not independent.